Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. I request everyone to attempt this question in the comment box. Don't worry, after some time you'll have the right answer with explanation. I believe we have tried, so let's start. Now the question, which of the below mentioned compound has maximum acidity? So here 4 compounds are provided. By the way student, if possible remember the name. This is called as cyanoform. This is chloroform, I guess you know. This is fluoroform. This is trifluidic acid. So actually 4 compound case I have asked who has the maximum acidity. So whenever the question will be given to you about acidity comparison, you need to check the stability of conjugate base or C. What is mean by conjugate base? If you remove the proton from this molecule, whatever negatively charged species remaining, that is called as conjugate base. And remember, higher the stability of conjugate base, higher the acidity. Means, logically if I say, if this negatively charged species is more stable, it will not try to gain back this proton. So this proton donation could be more easier. And we know what is strong acid. An acid which can dissociates completely, means the anionic part doesn't force to gain back the proton. So that's why if the conjugate base is stable, the acid is stronger. If conjugate acid is very stable, acid is very strong. Now if I say in this case, by the way student, I suggest you all to practice the drawing because structure drawing is very important. Now this triflet part is very important. Triflet means this trifluoromethyl is double bond both. So here the negative charge. By the way, I am not writing other structure because it is relatively more time consuming. So, and this is CHF3 similar like this, the chloroform, this 3F. Now, question, who is maximum stable? By the way, if you look at, so if you want to understand the concept clearly, you need to understand what kind of effects are operating to stabilize the negative charge or carbon ion. So actually we are talking about here carbon ion stability, and we know carbon ion means actually a electron rich species. So who can stabilize these electron rich species? Obviously who are electron withdrawing group, by obviously minus I effect or minus I effect or combination. So this is the overall basic concept regarding this problem. Now if you look at here, this is cyano, means carbon triple bond nitrogen. So here both minus I and minus R effect operational to stabilize. Now here if you look at, so you can say sir, there are actually 3 lone pairs on each of the chlorine. So can't they stabilize? Actually this lone pair could be donated, so it can show plus R effect, not minus I. So here this lone pair will not participate, rather than actually minus I effect of chlorine can stabilize, because we know with respect to carbon, chlorine is more electronegative. Not only that, this chlorine has vacant d orbital. What do I mean? 3d orbital. So that can also participate in conjugation such that this negative charge could be delocalized and stabilized. So here minus I, here also minus R kind of effect operates by vacant 3d orbital. Now what about fluoroform? If you look at here minus I effect is dominant, I agree, but there is another negative factor. See, this carbon fluorine bond distance is smaller. On fluorine also there are 3 lone pairs, and this carbon ion means it is also a lone pair. Agree? So it is also a lone pair, means there will be a significant lone pair repulsion, which could be a reason for such kind of unstabilization. You can ask the same question that, sir, isn't it possible here? This case lone pair, yes, it exists, but that is relatively lesser because this bond distance CCl bond is relatively longer compared to CF. So here minus I, and by the way fluorine doesn't have any energetically accessible vacant d orbital. I mean fluorine belongs to second row element. So there is no 2d orbital exists. So only vacant 3d exists. 2d cannot. So here only minus I is operational. But what about in this case? These case actually many resonance forms are possible. So it can donate, it could be stabilized. One canonical form. By the way, I'm not focusing on other these two SO2 CF3. Just I'm focusing on one. So one stabilization, I understand. O minus, here double bond O, CF3. Now not only that, even these negative charge, you can see here, it could be donated here, it could be open. So two equivalent canonical form, by the way, one here, equivalent canonical form. Not only that, there is a CF3 group which is a very strong electron withdrawing group or minus I effect showing group, and we know the minus I or electron withdrawing capability of CF3 is just in between fluorine and chlorine. So CF3 is actually stronger minus I effect showing group compared to chlorine, but it is just lesser compared to fluorine. So you can say it is a very strong minus I effect showing group, and such kind of three groups are present here. Just imagine these carbanion. I repeat, student, this carbanion is extremely stable. So if I say it's extremely stable, then you can say, sir, this trifluidic acid, it is extremely acidic. Actually, if I say technically, it is a super acid. Means it is stronger acid than concentrated sulfuric acid. So it is too much strong acid. So this is the overall discussion. By the way, you may think, sir, what is this? It is a CH bond which is acting as a super acid. Yes, it is true. So this is because the conjugate base is stabilized. By the way, I have already discussed dedicated lectures on many of these. I will go after some time. Now, if you look at acidity versus pK, why pK? Remember, lesser the pK, higher the acidity. Why? Because if you look at pK formula, pK is actually minus log 10 base concentration of H plus. Now, if an acid is strong acid, it will dissociate more. It will produce more amount of H plus ion. So, in solution, H plus ion concentration will be higher for stronger acid. Since there is one minus sign given here, so it says that okay, H plus is more. This log 10 base H plus value higher, but minus is given. Consequently, pK will be lower. So here who have minimum pK? So this is minimum pK. So you can say this is maximum acidic. By the way, this was our question. And now if you think that okay sir, this is actually it is stronger than even chloroform and fluoroform. This cyanoform is more stronger acid. Why fluoroform is lesser stronger acid compared to chloroform, I have explained. In this case, minus I and vacant 3d orbitals participation operates in order to stabilize the negative charge, but here only minus I. And another negative point is that lone pair repulsion. So although fluorine is more electronegative, stronger minus I effect, still chloroform is more acidic compared to fluoroform. So these are actually the resonance. I shall upload the links in the I button and description box. Please visit. This is cyanoform's acidity explanation. Next is trifluidic acid. It is actually super acid. CH bonds acting as super acid, rare example. And the third one, fluoroform, it is also a very interesting compound because nowadays CF3 chemistry or trifluoromethyl chemistry is getting attention because of lots of unique properties. So you may visit for further learning. So let's come back to our question. So which of the below mentioned compound maximum acidic? Obviously trifluidic acid. Now, if this question appears in your exam, so you may feel little confused. Sir, what is the relation? Why this is given? What are the relation among this compound? Actually, if you look at, these are all haloforms derivative. Now, cyanide is also called as pseudo halogen. So from that point of view, you can say, okay, all three have a relation. But what about this? This is one exceptional example where CH bond acts as super acid. So that is the actually asked point here. So that's why I suggest learn as much as you can. So I believe this video may be useful. You have learned a lot. So thanks for watching. If you really enjoy the content, then please hit the like button, subscribe this channel and share this content among your friends. See you in my next video. Bye-bye.